The simplest way to use a multimeter is for testing continuity, whether 2 points are electrically connected to one another. This is great for checking for solder bridges or cold solder joints within a circuit. Just make sure the circuit is unpowered before testing. First, turn the dial to the continuity setting. Then, connect the black lead to the common ground terminal and the red lead to the rightmost terminal. Then, connect the leads to each point in the circuit we want to test for continuity. If the multimeter detects connectivity between those 2 points, an audible beep will occur. If not, then no beeping shall occur. No beeping.
Here's my lady a tip for using continuity mode in a multimeter. Especially in a loud office, you can't hear the beep. Cradle it against your ears, and that way, when you do continuity test, you'll hear it nice and loud.
Nice. To measure the resistance between 2 points, set the dial to the lowest resistance setting, and then connect each test lead to each test point. If the multimeter simply displays the numeral 1 and a decimal point, that means we're trying to measure a resistance beyond the range of our current setting. Keep increasing this range setting until you see multiple digits appear. The dial is set to k ohms, or thousands of ohms, so we have a resistance of 9.88 thousand ohms. That's a lot of ohms.
You may find yourself needing to measure the resistance of a very small component, like the surface mount resistor here, and these multimeter probes are way too big. In that case, we suggest smart tweezers. Smart tweezers are basically a small digital multimeter, except instead of wire probes, there's 2 pointy tips. Grab the component with the 2 tweezer tips, then you can read the value off of the LCD.
Testing voltage is similar to testing resistance, but first we need to set the meter's dial to either a DC or AC voltage range. Here we're testing a battery, so we'll use DC ranges. Since I know this battery is supposed to provide 9 volts, I'll choose the smallest range that's larger than 9, which is 20 volts. It appears this 9 volt is not quite living up to its name, with a reading of around 4.3 volts. Sorry buddy, you don't have to go home, but you can't provide current here.
Don't forget, if you want to measure voltage inside of a circuit, it has to be plugged in and powered. If I have to measure a lot of voltages in a circuit, I like to use a probe multimeter. After you connect the ground contact, you can probe any voltage you want and see the result on the LCD.
Measuring current can be a little tricky because we need to route electricity through our multimeter, and it can only handle up to a maximum of current before blowing one of its internal fuses. The terminal on the right can handle up to 200 milliamps, and the terminal on the left can handle up to 10 amps, but it's not good at reading very small values. If you're unsure how much current you'll be measuring, but you know it's below 10 amps, connect to the 10 amp terminal and to the highest amperage setting. Then make a break in your circuit and connect the test leads across that break. It's showing 20 milliamps. That means I can safely switch to the 200 milliamp terminal and to a lower range. Now I can see that our LED is using about 15 milliamps of current. And my internal fuses are safe and sound.
The multimeters we're going to use in class look like this. It is the DT830B digital multimeter. They're fairly simple, but they do everything we need them to do. I just want to point out 2 areas of this multimeter that we're going to be using most of all. This section called DCV stands for direct current voltage. This is the kind of current that's going to be coming out of our batteries, normal 1.5 volt batteries all the way up to much larger batteries. And this is the kind of battery we'll be using. So we're going to be using this section. You'll notice several different options within DCV. starting from 200M, that stands for milli, so 1/1000th of a volt. This is just going to measure 200 millivolts at the maximum. And that goes all the way up over here to 1,000 volts. We could measure 1,000 volts with this digital multimeter. We're not going to be using anything nearly that high voltage. Almost everything we do is going to be using this setting right here, which is for anything between 0 and 20 volts. So we want this setting a lot. Off, of course, is very useful. It turns the multimeter off. And we're going to need this section over here, DCA, stands for DC amperage or DC current. So we also want to be able to measure the current in a DC circuit, and we're going to mostly be using these last two settings down here. One is for 200 milliamps, and this is for 10 amps. So we could measure anything from 0 up to 10 amps of current on this setting right here. Over here on this side, you can see the ohm symbol. We'll learn a little bit more about that when we go into resistance in more detail. But basically these settings over here are going to allow us to be able to measure resistance. And we'll learn about that a little bit later. Okay, here is our multimeter. It looks like this, and it comes with a red cable and a black cable. And these cables have two different ends. One end has a right angle. This is the end that is going to plug into the multimeter itself. So if you remember, I need to plug in my black probe into COM, just like that. In order to measure voltage, I want to plug the red probe into this port right here. You can see it says V omega MA. So the V is your reminder that it's for measuring voltage. And then we're ready to begin measuring voltage on. I have here a battery and a bulb. Let me turn off the overhead light, and you can see that the bulb lights up. So off, on. So my circuit is closed. If I want to measure the voltage across this light bulb, if I want to measure the voltage across this light bulb, I need to turn my voltmeter on to DC 20. This means it's ready to measure anything from 0 to 20 volts. And what I do is I place the red probe on the positive side of the component. Positive side means the end that is most towards the positive end of the battery. Where's current coming from? I put the red probe there. And then I put the black probe on the other side. Oops. Red probe to where current is coming from. And I put the black probe on where current is going out of the component, back towards the battery. And you can see the voltage. So the voltage across this component is 1.46 volts. So we can go back and learn about how to measure current. Circuit, we'll notice it's the same circuit. I have a battery and a light bulb, and if I close the circuit, my bulb lights up, which is great. In order to measure current, I have to do a few things differently. It's not like measuring voltage. The few differences are these. The first step I need to do is make sure I change my red probe to be plugged into 10 ADC. Yeah, I'm going to zoom in, and you can see that it's plugged into the 10 ADC port. Next, I don't turn it to the same place. I turn it over to 10 amps over there. So when I turn my dial to that setting, this multimeter is now ready to measure current anywhere from 0 to 10 amps of current. To measure current, we actually need to make the current pass through the multimeter. Otherwise, the multimeter doesn't know how much the current is. So in order to make current pass through the multimeter, we actually need to make a gap in the circuit. And I can make a gap one of two places. I can make a gap right before the component that I want to measure current through. There's actually a gap right here. There's a gap between this point and this point right here. There's my gap. Or I could make a gap right after the component that I want to measure current through. So there's a gap between the end of the light bulb and the wire that leads current away from the light bulb. So I'm going to choose to make the gap over here. I'm going to place my black probe on the negative side of the circuit. Current is returning to the battery that way. So that's where I'm putting my black probe. And I'm going to put my red probe to complete the circuit. And you'll notice that the bulb lights up again. The bulb lights up as soon as I touch the probe to the end here. And that's because current is now flowing again through this circuit, even though there's a gap here. There's no longer a gap in the circuit. The current is actually flowing through the bulb, all the way through the red wire, in through the multimeter, back out through the black probe, back through the black wire to the battery. So this actually makes a complete circuit, and now it gives me my current in amps. The units of currents are amps. So this is 0.22 amps through this circuit. Notice when I release the probe, the current goes to 0, or in this case almost 0, 0.01. So we have a little bit of a calibration issue with this multimeter. But closing the circuit allows current to flow through the multimeter, and now I can see that I have 0.22 amps of current.